Hello friends. This video is brought to you by mywayteaching.com.
Till now we have discussed about intersecting lines. Now let us proceed to parallel lines and a transversal. Let us recall that a line which intersects two or more lines at distinct points is called a transversal. Observe that four angles are formed at the point of intersection. Let us name them from angle 1 to angle 8. Then angle 1, angle 2, angle 7 and angle 8 are called exterior angles. Angle 3, angle 4, angle 5 and angle 6 are called interior angles. Angle 1 and angle 5, 2 and angle 6 are corresponding angles. Similarly, 8 and 4 and 7 and 3 are corresponding angles. That means we have 4 pair of corresponding angles. Also angle 4 and 6 are called alternate interior angles. Similarly, 3 and 5 are alternate interior angles. So we have 2 pair of alternate interior angles. Next are alternate exterior angles. Angle 1 and angle 7 is one pair of alternate exterior angle. Similarly, angle 2 and angle 8 are alternate exterior angles. And lastly, we have interior angles on the same side of the transversal, which are also called co-interior angles or allied angles or consecutive interior angles. In this figure, angle 4 and 5 are co-interior angles. Similarly, angle 3 and 6 are co-interior angles as they are occurring on the same side of the transversal. If we have two parallel lines which are cut by a transversal and we measure pair of corresponding angles 1 and 5, 2 and 6, we will find that angle 1 is equal to angle 5 and angle 2 is equal to angle 6. Similarly, on measuring we can find that angle 8 will be equal to angle 4 and angle 7 will be equal to angle 3. So this fact can be considered as an axiom which says that if a transversal intersects two parallel lines, then each pair of corresponding angles are equal. Converse of this axiom is also very useful. Now suppose if we don't know whether the two lines are parallel or not, then we can draw a transversal, and if we can find out one pair of corresponding angles to be equal, then we can conclude that the given lines are parallel. So the converse of axiom 3 states that if a transversal intersects two lines such that a pair of corresponding angles is equal, then two lines are parallel. Let us use the corresponding angles axiom to find the relation between the alternate interior angles. Let us prove the theorem that if a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. In the figure, PS intersects lines AB and CD at point Q and R. It is given that AB and CD are parallel. Then we have to prove that angle AQR is equal to QRD as their alternate interior angles, and BQR is equal to QRC. We start our proof by saying that angle PQA is equal to angle QRC by the corresponding angles axiom. Also, we can see that angle PQA will be equal to angle BQR as they are vertically opposite angles. Let us mark the two results as 1 and 2. From 1 and 2, we can see that PQA is equal to QRC and PQA is equal to BQR. That means these two are equal. Hence, we have proved the second part. Similarly, if we start with angle PQB and QRD to be equal because they are corresponding angles, and then PQB is also equal to angle RQA as they are vertically opposite angles, we can reach the result angle AQR is equal to angle QRD. Hence, prove the theorem. So we have that if two lines are parallel and if a transversal intersects them, then the corresponding angles are equal and the alternate interior angles are also equal. Converse of the previous theorem is very useful if we are required to prove that the given two lines are parallel. Converse of the theorem is that if a transversal intersects two lines such that pair of alternate angles are equal, then the two lines are parallel. We have another theorem which will be very useful in solving the questions and proving more results. It states that if a transversal intersects two parallel lines, then each pair of interior angles on the same side of transversal is supplementary. That means from the figure, angle 4 plus angle 5, which are co-interior angles, will be equal to 180 degrees, and angle 3 plus angle 6 will be equal to 180 degrees. Converse of theorem 2 is also true, and it can also be used to prove that two lines are parallel. According to converse of theorem 2, if a transversal intersects two lines such that pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. Let us now prove the theorem that the lines which are parallel to the same line are parallel to each other. If L is a line and we draw a line M parallel to line L and another line N which is also parallel to L, then we are required to prove that M and N are also parallel. Let us draw a transversal T such that it crosses line N as well. Since line M is parallel to L, then by our axiom of corresponding angles, angle 1 is equal to angle 2 as they are corresponding angles. Also we have drawn line N parallel to line L. So angle 1 will be equal to angle 3. Again they are corresponding angles. From equation 1 and 2, we can see that angle 2 is equal to angle 3. By the axiom, if a transversal intersects two lines such that the pair of corresponding angle is equal, then the two lines are parallel. Angle 2 and angle 3 are corresponding angles for line M and N, and we have proved that they are equal. This implies that line M is parallel to line N, and we have proved the theorem which states that lines which are parallel to the same line are parallel to each other.